we do a lot of difficult deployments. We go to the desert, we go into the sea. Sometimes it's fun, sometimes it's not. But you want to be able to have anchors you can rely on and keep on doing what you need to do when nothing is working. And that is, I think, the only way to do that is if what you're doing is meaningful work.
Right, and that's a really good kind of point as well, is when you're doing something and it doesn't appear to be working, how do you keep your team motivated to keep trying and keep finding new ways?
Fastlane Founders and Legacy with Jason Barnard. Each week, Jason sits down with successful entrepreneurs, CEOs, and executives and get them to share how they mastered the delicate balance between rapid growth and enduring success in the business world. How can we quickly build a profitable business that stands the test of time and becomes our legacy? A legacy we're proud of. Fastlane Founders and Legacy with Jason Barnard.
Hi, everybody, and welcome to another Fastlane Founders. I'm Jason Barnard, and I'm here with a quick hello, and we're good to go. Welcome to the show, Amarjot Singh.
Glad to have me, Jason.
And I literally just realized that your surname is perfect for that introductory song because I'm singing.
That's great.
And that's not a very funny joke, but I had to make it because as I sing, I thought that's good. Anyway, let's get on to the topic, which is going to be about building adaptive AI. And I just asked you, are you basically building AI that learns like humans, replicating our brains? And you said something along those lines. So we'll be getting into that in a moment. But before we go on to that, I wanted to show you the Gemini result for your name, which is pretty good. I asked it to tell me about you. And it comes up with a reasonably good answer. I quite like that. And I think your academic background is what it picks up on. And then it's moved on to your corporate background, which is now. But then I thought, let's use deep research, which I'm really enjoying. And I've made a video because it's really long. And it's really long because it knows so much about you and there's so much information about you. So the idea here is I asked deep research on Gemini to build a plan to tell me about you. And it built a plan and then it executed it. And you can see that table, that's a lot of information about you and your academic work. It goes through an entire history of your life, which I believe is pretty accurate with that second table there. It's got 7 sections all about your life as an academic, the work you're doing with Skylark. And it literally doesn't stop. And I'm crazy. This is something we all need to pay attention to and we all need to take care of, because if I want to know about you, I can ask Gemini and it will tell me a quick overview like that. And it needs to get it from its, is it called memory in the brain?
Yeah, hippocampus.
And then if I asked it to dig down and figure out more and go into its long-term memory that it doesn't necessarily have in that hippocampus memory, it then does this. And it's kind of a due diligence using AI, which I love. And at CaliCube, it's exactly what we do for our clients, is make sure that that is accurate and convincing for your audience. And I think for you, it already is because of your academic career.
Yeah.
Because Google and the other AI have got so much solid information about academia and they trust those academic institutions.
Yeah.
How do you feel about that?
I feel like that's great. I'm actually kind of overwhelmed that once you showed me that that table and the 7 sections, that there is actually so much information out there about me. Now I wonder if all of that is accurate, or if I wanted to tweak it in a certain way so that I come off as more appealing to the investors or other entrepreneurs or our clients. And that's the thing I'm thinking about.
That's a great point, because the whole thing about pivoting, I mean, you've pivoted from academic research to building a commercial AI company, is really, really important, because how you frame it across your entire digital ecosystem will greatly influence how the machine frames it. So as you said, if you want to convince investors, you need to convince them that your academic qualifications are there, but that you can actually make money for them. And it's up to you to frame it. It's up to you to spread that message so that the machines will repeat it. And that's what we do at CaliCube. But I'm now interested in, how did you move from academic research to building a commercial AI company, particularly in defense?
Yeah, I think so I did my PhD in the UK all of my work
Cambridge.
was Cambridge. I went to Cambridge. I was there for
That came from deep research. Sorry.
no, that was great. I had a great experience, and Cambridge is all about building fundamental technologies, and that's what I did. So I studied the human brain. I was trying to figure out how the brain is able to make sense of the world, how kids
Uh-huh.
make sense of the world, but they're able to do it really quickly, within seconds, while machine require a lot of data. It requires a lot of compute. So I was interested in simplifying how machines could do the same thing. And I was able to an extent, able to do that. But beyond that, I was trying to figure out what are the practical applications of this and the kind of things I wanted to do with that tech. It's hard to do in academia because it requires a lot of capital, it requires a lot of real world data, and it requires a lot of real world testing. And the simplest solution I had was to start a company so that I could do what I wanted to do. Yeah, and also, yeah,
No, I did that too. I created the company so I could do what I wanted to do. But that makes me think the problem that AI has is reacting or being able to react appropriately to situations it has never seen before, whereas a child is able to do that. And the fundamental difference is what you've figured out.
Yeah, so AI traditionally learns from large data sets, large compute, while I'm able to tell you whatever I'm able to tell you right now, and you're able to learn it within seconds. So our brain has the ability to do long-term learning and reasoning and also short-term learning and reasoning. And that is the thing which is missing in traditional AI systems, which we are trying to build in our company. And if you are able to do that, then you will be able to put this AI onto machines which are able to go operate in the real world and learn if needed, leading to truly autonomous systems, which we don't have today because still we need to update them continuously. And that is the gap we are trying to bridge.
Right. And in defense in particular, the situations the AI is seeing are
Yeah.
more often new
Yeah.
and also require instantaneous decisions that need to be right.
Yeah, because in defense, if you have a system which is working in the battlefield or a system is on top of a drone, you cannot bring the machine back, update it, and send it back. You need to take decisions then and there. And that is where adaptive AI is really valuable.
Right. Okay. So let's come back to the brain idea. I mean,
Yep.
we all talk about AI as being some kind of replication of the human brain or an attempt to replicate the human brain. Is your particular approach much closer to that reality than everybody else's, and why?
I think I would say that we are trying to learn from the principles of the brain rather than trying to replicate everything. And yeah, functionally, we want to learn at different time steps. We want to be able to learn quickly, and we want to be able to learn with very little compute. And that's what we are trying to replicate. And I think we have been able to do that to some extent because our AI is able to run on edge devices like CPUs, Raspberry Pis, things which are really low compute, really low power, and they're able to learn new things instantaneously. And then obviously they are able to retain it over a period of time like humans retain knowledge. So if you are able to fundamentally achieve those three functions, I would say that at least you're able to perceive the world like humans do and operate in that rather autonomously than having a human in the loop.
Right. So when you talk about retaining information, would that be the difference between this very short answer and this very long researched answer where it went out onto the web and found new information to supplement the incredibly short answer that it initially gave me?
I think the short answer is basically a summary of the long answer. Both of them are long-term knowledge, which basically it has pulled from whatever places where this long-term knowledge exists. But if I add something new right now onto my website, it may or may not appear right away in this search. And as you mentioned, would depend on if that information is relevant. And if it is relevant, then Google will crawl it and it'll retain there for a period of time. And over a time, if the credibility is there, it'll permanently keep it. Otherwise, it'll get rid of that. And that's what we try to do. The short term knowledge is looking at something relevant and then crawling it and bringing it in front of the user. And if the credibility of that source remains over a period of time, we will solidify it, we'll keep it in a long-term knowledge, otherwise get rid of that.
Yeah, I really like the idea of the credibility remains over a period of time, because people often forget, or don't realize that the period of time that a machine sees a piece of information from a perceived credible source or multiple credible sources and becomes confident because of that credibility and because of the time, the more likely it is to retain it long-term. And it's that long-term memory that we're aiming to hit.
Yeah, that's very important, because information changes over a period of time. The credibility of information or the importance of information changes a period of time. And that is something which also these systems or the current AI systems don't really tap into, because whatever information they have learned is static and the world is changing. So if you're operating with the same tool in a changing world, you're gonna be left behind. And that's where humans come into play, where they have to update the system so it keeps in pace with the changing world. And that's what this short-term, long-term memory would fix.
Right. So what I'm now kind of thinking as you talk is the concept of long-term, short-term memory is incredibly important to the work that we do. Would there be a mid-term memory, or is that a silly idea?
No, so memory is continuous. It's not short-term or long-term. We just say it's short-term, long-term because it's easy to program into machines. But memory is continuous. So there are some concepts, some experience you had when you were a child. Maybe you remember the street you were playing on, or maybe you got hit by a bicycle and you remember that. And those are events which happened once in your lifetime, right? But you remember them, and that's long-term. But maybe you spoke someone to an hour ago, and they were a person from a credit card company, and they were supposed to just tell you something about your credit card. As soon as you put the phone down, you forget about that. So traditionally, we encode information which is based on frequency. It's frequent, it's recent, and it has some sort of importance factor to it. So we understand frequency and recency really well. If there is let's say, links to your website, and you have a lot of links, there's a lot of high frequency, so that's a trusted source. And if it is some information has come recently, we can say that, okay, that's more important. And then obviously there is some sort of importance factor, that it's Reuters or it's TechCrunch or it's Google, so they are like trusted sources. But beyond that, there are other factors as well which kind of control as to how we retain knowledge, which we don't really know much about. Hence the example, which I just gave you.
Sorry, those are the three big ones.
Yeah, those are specific ones,
Frequency, recency, and importance. Yeah, because in knowledge graphs, I talk about close, strong, and long relationships. Yeah. Those are the ones that you retain, or that become the most influential. Would that be importance?
So short and long, we know it's frequency and recency. How importance works, we don't really know. Why do we forget the name of a person who we just spoke to because they were just from a credit card company and we don't really care about? Or when you're playing cards and you have a hand and you put the cards down and you get the next hand and you forget about that hand right away, right? It's a very frequent, it's a very recent event, and you play cards frequently. But why do you forget about that right away? So there is something going on in the importance factor, which tells you that that's not important, but you do remember a memory from your childhood, which happened once. Maybe someone hit you, but you remember it because importance is really driving that. Although frequency and recency over there is really low.
Right. So in fact, it's perceived importance.
Depends on like how the brain perceives it. What is important for me can be very different for you. So yeah.
All right. No, sorry. This is that in my brain going off on different things. Let's come back to business. How do you deal with the long sales cycles in the defense industry? I imagine they take decisions over multiple years. They're big numbers, but you have to wait 2 years for them to actually make the decision. It goes up the hierarchy.
I think there are ways of cutting them shorter, compressing the timelines. So the best way to do this, when you're a young company, you don't want to go and grab the bull by the horns all by yourself. So you work with a trusted partner or a defense prime and they already have contracts secured from the government. So you work with them, and in the process, you build your name. And then after 2 years or so, you're in the process to go and get those contracts yourself. So in the process, you have learned how the process works, what kind of security clearances you need, how much money goes into doing all that stuff. And that's how we try to secure things. Um, Unless there are certain provisions for small businesses where we get an advantage, that's the only time we do things direct. Otherwise, we would partner with bigger people. And that also adds to the credibility because someone big is willing to work with us.
Right. Okay. That's a really good answer, and I've been doing it all wrong at Calicube, so that's brilliant. When you're building a team, obviously you need super specialized expertise, and it's a problem we have at Calicube for the production aspect of what we do. And it's not obviously as specialized as what you're doing. How do you deal with that? How do you find the people who can actually do the kind of incredibly advanced brain work that you require?
I think people have to be so in order for you to add smart people to your team, you have to figure out what they're driven by. One is obviously they're driven by how much money you give them. And as a small business, we cannot compete with the likes of Google or Facebook or whoever that is. So the other thing which drives them is um, the work they're doing has a potential of making a great impact. If you're able to weave that into the work they're gonna do, and they have actually seen you do impactful work, they would likely want to come and join and work with you rather than going and working with a bigger company. The other thing which we really focus on is autonomy. We want people to do what they want to do, what they're good at, and we give them a free hand. And then they come up with either excellent ideas or they fail miserably. Both are okay. But till the point you don't micromanage people, you make them in charge of what they want to do. And that has a potential of really making a big impact in the real world. People would come and want to work for you.
Okay. So fun, autonomy, or doing something you enjoy rather than fun. I mean, I talk about it as fun, but doing what you enjoy is usually important.
Yeah. If it's meaningful, I think people will do it, even though if it's difficult. And work is fun sometimes, especially for us, and not all of the time because we do a lot of difficult deployments. We go to the desert, we go into the sea. Sometimes it's fun, sometimes it's not. But you want to be able to have anchors you can rely on and keep on doing what you need to do when nothing is working. And that is, I think the only way to do that is if what you're doing is meaningful work.
Right, and that's a really good kind of point as well, is when you're doing something and it doesn't appear to be working, how do you keep your team motivated to keep trying and keep finding new ways?
Yeah.
Right. Okay. Next question is, how do you protect your IP?
Yeah.
Your intellectual property across countries, working for the military. That's a huge question. You must have a lot of IP, very difficult to protect.
Yeah. So I think like one is that we have obviously patents, which we filed. And that's one way of doing it. But it's very hard to protect a patent once someone infringes it. You don't want to go through a very long battle. So the best way to do that is compartmentalize your company. So people who are doing machine learning, they give encrypted codes to people who are doing production and goes back and forth. So you want to be able to like create as much silos as you can in your company and only share raw code if it is essential. And the other way of doing that is that people don't really get to blame each other. They don't really get to say that, hey, this was someone's code and I changed something because I thought it was a good thing to do or a bad thing to do, which always creates chaos and friction between companies. So if you can create silos and they're encrypted and you can create firewalls, and if you're able to build a product using that, I have found that to be the best way of keeping things secure.
Brilliant. Next question then is, you're using the brain as a way to improve AI rather than trying to duplicate or replicate the brain.
Yeah.
To what extent have you succeeded? And to what extent, or where do you think it's going? Where do you think you're going? We're all going next. Yeah. How fast is this going to evolve?
Yeah, I think that's a really important question. I think the fundamental pillar which we are building is the pillar of adaptability. We want machines to adapt. If you are able to build that, which we have done for certain applications, trying to journalize that, you get to journal intelligence. You get to actually build intelligence which works for most of the applications, have fixed knowledge, and have the ability to adapt. Now, if you're able to embody that into different kind of machines, be it humanoids, robotic dogs, drones, towers, which we do, you have embodied intelligence or embodied journal intelligence. And if you actually have that, eventually you will have digital citizens, digital humans, digital beings, whatever you want to call it, which would have the ability to live among ourselves and operate and do most of the things which we do today, giving us the freedom to do what we actually want to do. And that'll be a world where humans and digital beings will coexist. And that is where it's headed.
How long do we need to wait?
Probably around 5 to 10 years. It's not that far away.
Wow. I think we can end there. That's the most delightful ending to an episode I think I've ever heard. Thank you so much.
I appreciate it.
Amarjot, that was brilliant. It was a really interesting conversation mixing AI, machine learning, and business. And I really enjoyed it. I got a lot out of it. Thank you so much. You get the outro song. Yeah, great. That'll be great. I get to and it's so. Thank you, Amarjot.
I appreciate it, Jason. Thank you for having me.
Thank you. Delightful.
Your corporate and personal brands are what Google and AI say they are. We can give you back control. Calicube.